am Enrique Casas. I am a member of the University of La Laguna team, which is coordinating and participating in task 4.1 within activity 4 of the MOVE project. And our objectives in this task is to develop and test mapping tools for ecosystem services in outermost regions and European overseas countries and territories. So the main motivation of the MOVE project arises, as Harun introduced already, from European Biodiversity Strategy to 2020, which states that every member state will need to map and assess the state of ecosystems and the services, as well as the economic value of those services, and promote the integration of these values into accounting and reporting systems. So reviews on ecosystem services and biodiversity databases show an alarming lacking of information regarding geographical coverage of this mapping and assessment of ecosystem services implementation. And that's especially important in European outermost regions and overseas countries and territories, which are actually where almost all European biodiversity is held, with, for example, 20% of the world's coral reefs and lagoons in these territories. So before I go on, I will just give a brief approximation of what ecosystem services are, in case some of you are not familiarized with the concept. So ecosystem services can be understood as any good benefits, profits, or benefits to human well-being related to biodiversity and normal functioning of ecosystems. So it's an anthropogenic-centered concept that aims to assess the value of ecosystems and to express this value in a straightforward language that could be clearly understood by society and policymakers. So it aims to be a convenient tool for policy making. So, well, as I said, in this particular task we're talking about today, we're aiming to develop on one hand and then test and validate mapping tools for these ecosystem services. So in order to develop these mapping tools, we want to implement regional contributions and address knowledge gaps and specific partners and regional stakeholders' requests and expectations in these regions. And we of course, we want to do it, as Haruni said as well, by involving the regional stakeholders. This is really important for us. And it is with involvement of the stakeholders and their collaboration how we will be testing and validating these mapping tools. So in order to develop these mapping tools, we implemented 7 regional case studies and 1 cross-regional case study as well. And these regions are seven regions of Europe, and we have the Azores, Canary Islands, Saint Martin, Martinique, French Guiana, the Falkland Islands, and well, of course, La Reúnion. So as I said, we implemented 7 cases of study in these regions and 1 cross-regional case of study. And I will give you a brief overview of what we've done in each region. Of course, I won't go in detail on La Reúnion, as we will be having a really nice presentation presenting the methodologies used and the results achieved. But for example, in Martinique, coastal protection, nutrient uptake, and fish biomass production were assessed related to coral reefs by linking ecological condition indicators with ecosystem service provision and their monetary value. In Saint Martin, commercial fisheries, tourism activities, and carbon sequestration were assessed related to seagrass communities, coral reefs, and mangroves, by calculating the total ecosystem size based on polygon areas and determining and quantifying their economic value based on a set of parameters for spatial allocation. In Canary Islands, commercial fisheries, the economic value of commercial fisheries related to Cimo d'Oceano Dosa meadows were assessed using habitat suitability mapping and value transfer methodologies. For the Azores, recreation, pollination, carbon estrage, nutrient delivery ratio, and sediment delivery ratio, and flow retention were assessed for all terrestrial habitats of Terceira Island using 3 geodata sets and quantifying these ecosystem services with INVEST models. For the Falkland Islands, blue carbon and stock and sequestration, along with nutrient cycling and commercial fisheries and alginate production, were assessed relating to kelp forests, and using remote sensing to identify the kelp forest extents, along with density estimations and ecosystem services economic valuation already published. And for French Guiana, a broad range of ecosystem services were assessed for 23 different ecosystem types present in the Guiana Shield by using metric methods based on expert consultation and quantifying the ecosystem services with index models using land use land cover data from 2005 to 2015. So that's broadly what we've been doing in this region with these cases of study in order to develop these methodologies to map and assess ecosystem services. And the other part I was talking about is it's about testing these mapping tools and validating these methodologies already implemented. So in order to do that, as I explained, we really need the stakeholders' feedback and involvement. And to do that, we developed a questionnaire and a series of webinars like the one we're having now, and some workshops where we were presenting the methodologies implemented and the results obtained in order for the stakeholders to give us feedback on these methodologies. So this is one example of the kind of feedback we were expecting from this kind of questionnaire. In this particular example, there's a representation of the kind of information we're looking for. And as you can see, we are expecting to retrieve some feedback on the regional stakeholders relating to the main activities and areas of activities they develop, to see, depending on the kind of activity stakeholders is developing, how good or how convenient or how useful could be this tool for future mapping and assessment of ecosystem services. So finally, with this feedback and this important information from the stakeholders, we aim to first, to construct a series of deliverables for the project. One of them is a compilation of all technical reports from this case of the study implementing, along with the questions, with the answers from these questions of the questionnaire I was talking about. And then a really important one too actually should be some best practice guidelines for both marine environments and terrestrial environments. And these best practice guidelines aim to be constructed with this feedback to see how good and convenient this tool could be to assess future mapping and assessment of ecosystem services. And this is, of course, one of the objectives of this case of study. We're going to have a presentation today from La Reunion. I think it's a really interesting one, and I hope you will enjoy it. So I'll just give room to it, and thank you very much.
Hello, everyone. So today I will be presenting our case study, which is La Réunion. So the study has been developed with my colleague, postdoctoral fellow, Alexandre Rifas. So we will be introducing you to the assessment of some ecosystem services in the terrestrial and in the marine domain in La Réunion. Briefly, our objectives were to map and assess a subset of ecosystem services, meaning some provisioning services, regulation and maintenance services, and cultural services. The study aims to be illustrative for stakeholders, so there's no way we are going to do an entire or complete assessment, but it's just we're just showcasing what can be done in terms of ecosystem services assessment and how this could impact terrestrial and marine management in marine. So we wanted to do this study seamlessly across the terrestrial and the marine domain. So first, I'm going to introduce La Réunion. So La Réunion is a small island, 2,500 kilometers. We are 700 kilometers away from Madagascar, and we are surrounded by the deep ocean, 4,000 meters depth. And we are quite close to Mauritius, 200 kilometers. So we are in nutrient-poor waters, and the island is 3,000 meters high, 40% of the island is covered by a national park, by the core area. And in the lowlands, up to 1,000 meters high, you will find sugarcane fields and pastures. And there is 800,000 inhabitants, so it's quite populated, almost 1 million. And the population is mostly distributed along the coastline. So the windward side received 4 meters of rainfall per year, where the leeward side is more dry with less than 1 meter. We have a very, very small marine protected area covering the coral reef along the leeward coast. The first step of an ecosystem services assessment was this habitat mapping. So this is the keystone information we want to gather, we want to collect. So first, an habitat of terrestrial habitat was needed. So we don't come from nowhere. There's been a lot of work done in Réunion over the past 20 years, mostly by Strasberg and team. And they published in 2005 a map of pristine vegetation with the current status and the initial status before human settlement in 1640. I expanded it in 2011 to 44 categories to include transformed habitats. So we now have a seamless cover of habitats, both transformed and pristine, over the island area. I updated it using data from the Agora, the urban agency of Reúnion, so for the year 2019. And finally, we have a map simplified with 25 categories. So this includes lowland habitats, submountain habitats, mountain habitats, subalpine, wetlands, coastal, and lava flows. And all is under a tropical climate. I'm going now to talk about the coastal habitats. We are talking here about a map of coral reef. We've been focusing on coral reef. A first map was done by Nice in 2016, completed by Cuvilliers for seagrasses in 2017. And more recently, Bejuk and colleagues used ground truth data and LIDAR data to map 13 reef habitat classes. So it's quite a detailed map of coral reef we have. And now the big part was, the big trick was the ocean habitats mapping. How do you map habitats? We developed an habitat classification using remote sensing data. And we applied a classification method on those MODIS data to develop a system of habitats that would act as a keystone for mapping ecosystem services in the open ocean, well, at least the surface. And the method is described in Robertson et al. In 2017. So it's a study I was involved in, and we developed that to map key areas for conservation in South Africa. So you can find the reference online. First, you need what? Bathymetry data. I won't go into details for those bathymetry data. We have quite a lot of those bathymetry data in Reúnion. We have LIDAR data at 5 meters resolution from 0 to 30 meters depth. We have a 100-meter resolution, also bathymetric map. And on the right map here, you will find a map of the different benthic ecological zones from epipelagic, mesopelagic, bathypelagic, and abyssopelagic according to the depths. What types of remote sensing data did we use? So we used the turbidity, which is the parameter KD490, the chlorophyll, and the sea surface temperature. And the idea is to capture the mean state of the ocean, but also its variability through time as one of its properties. So we map the mean and the coefficient of variation of the turbidity on the left. So as you can see, there is clearly an island effect where you find the highest turbidity around the island. Similarly for the chlorophyll. And on the right, we'll find the night sea surface temperature showing latitudinal gradient, which is logical from north to south, and with the hotter water at the equator. And here on the west side of the island, you can see an island mass effect with warmer temperatures. We wanted to validate those data against ground truth data. So we collected data, ground truth data, and we found a good correlation between remotely sensed compressive spectrometer and chlorophyll alpha, and measure at 4 coastal stations along Réunion Island. So data were validated. So you put it in a shaker, you classify it, and you obtain a map of clusters here on top left A. And as you can see, those clusters are organized along latitudes, except one, which is the little yellow one here, the cluster number 5, which is the coastal cluster. So it's clear from this classification that the coastal water mass are different from the open ocean water masses. And here we mapped it from remote sensing data. So now we have a map of terrestrial habitats, a map of coral reef habitats, and a map of open ocean habitats, plus a map of bathymetric zones. We want now to assess what is the habitat condition. So is it in a good state or not? For terrestrial habitat, I will cite the work that has been done by the working group on the spatial prioritization of actions on invasive alien species, the GCEIP, in 2019, driven by Lamy and Rouget. So they transmitted their data, and I thank them for that. So what they did, they assessed the level of invasion of pristine habitats. Here, in green colors, and from red to yellow, what you see here is the transformation status based on the map I did in 2011. So here you have a complete mapping of the transformation status of habitats, including the level of invasion as mapped by Ami and colleagues in 2019. Mapping the status now of coral reef habitats. There's been a set of studies. Bejuk et al. In 2019 assessed that there was a loss of the coral cover class by almost 90% between 2009 and 2015, which is quite worrying. Another study recent by Tedeti found that the eutrophication of the southern part of the reef through higher phytoplankton biomass. There is also the work being done in the framework of the GCRMN study linked with the monitoring of coastal water masses as the implementation of the law on water by the directive, the European directive on water. And here you can see the online map showing that the coastal water masses has a status that's comprised between average and good. Now, what is the state of ocean habitats, the cluster we map? The status of deep benthic habitat is still poorly known, and also the status of open ocean water masses. But what we know about is the fish stocks. And Lemanak et al. In 2015 showed a decreasing trend for both artisanal and domestic fishes and industrial catches along the coastline and in the EEZ. And Fleury in 2011 showed the overexploitation of demersal fish species. So there is a real depletion of fish stocks, at least the demersal ones along the leeward coast. And at the scale of the Indian Ocean, you will find the data at the Tuna Commission, which has the mandate to assess those, the status of fish stocks. And over 12 species being assessed by the IOTC in 2019, 4 species are considered overexploited. Also, in terms of trends, I will focus on the right, on the graphic on the right, which is the night sea surface temperature, with all the temperature from 2003 up to 2017. And as you can see, the rainbow colors are still found on the graphic, which shows an increase in temperature, even more marked in winter, and we can estimate that to almost 1 degree of warming over those years along the coastline of La Réunion. Climate change is a matter of worry. Here I've shown you a study published by Guerry and colleagues in 2014, showing the expansion of unsuitable thermal habitats with a temperature higher than 31 degrees for different IPCC scenarios. So as you can see, the Indian Ocean is concerned with a spatial expansion of those unsuitable thermal habitats over the next 100 years. Okay, so now we have a map of habitats. We know the status of those habitats, and for at least for some of them, and for also some species or group of species. Now, how can we use this to assess ecosystem services? First, we selected the types of ecosystem services. So for terrestrial ecosystems, we assess the carbon stock. And on the right side of this table, you will see the CSS codes, the corresponding CSS code, which is the classification of ecosystem services that we are using. So it's a normalized classification of ecosystem services. For coral reef and associated coastal ecosystem, we assess the following services. So fishing, regulation of coastal erosion, and coastal blue tourism activities. For ocean ecosystem, we assess also fishing and net primary production of the ocean, plus carbon stocks. We will discuss this later. So assessing the terrestrial carbon stocks, carbon stored in terrestrial ecosystems plays an important role in the global carbon cycle. It is stored in live biomass, in the soil, and it is exchanged with the atmosphere through photosynthesis, respiration, decomposition, and combustion. What can alter the ratio of carbon is climate change and land use changes. So what we did is we assessed carbon values for broad habitat units categories, for above ground, below ground, soil, and dead organic matter, for the 25 habitat categories we found. I insist that this is only a preliminary result. This still needs improvement. We were not able to fill all values. So I'm sure during the next weeks, I'm going to interact with my colleagues to fill some of the missing values. We also based it on a literature review, and we found a very close study by Virgilio et al. In 2016 developed for the Azores. And we also use classically the IPCC values based on the 2019 refinement of the IPCC 2006 guidelines. And to avoid overestimating carbon storage, by default, we applied a value of 0. The table is here. You won't be able to read it. It's only a work in progress. It shows in lines the habitat types and the amount of carbon and the source we used to fill those values. And the resulting map is the following. So I insist, it is still a work in progress. So for 2019 on the left, compared to the spatial distribution of carbon stock before human settlements. From this, we can conclude that the stock is higher on the windward side than on the leeward side. And through this study, we showed that the average carbon stock is 10,000 tons of carbon per kilometer square in 2019. And it was closer to 15,000 before human settlement. So it's a loss of minus 33% of the stock. How can we discuss those results? If you want to put a monetary value behind it, you will find that the value is approximately 2,000 kilo-euros per kilometer square. And if you want to compare it with the value found in Pico Island in Azores, we are more or less with the same values. I think our values are lower because we have higher active habitats and we are still missing a lot of data for carbon stock in soils. I did also an assessment and I found that well, we will have to confirm that with my colleagues specialized in this domain, but we assess that with the carbon emitted by cars in La Réunion consumed is equivalent to, in 4 years, is equivalent to the carbon stock of La Réunion. So now we are going to move to coral reef ecosystem services. For that, we based our work on the study by Pascal et al. Published in 2013 and 2016. And they found that the monetary value of fishing services is valued to 10 million euros for coral reef, which is 500,000 per kilometer square of coral reef. The protection against coastal flooding is estimated to 13 million euros. So it means that the value of, for instance, all the houses and the commercial activities that are protected, sheltered from the reef, then this is their value. And he also says that coastal boat tourism can be valued to 30 million euros per year, which is 1.5 million per kilometer square of coral reef. In 2016, there was 230,000 visitors. Those figures increased since then. So we have more and more tourists in La Réunion, even now this year. And I wanted to compare that also with other numbers. So in a study, Faberge in 2014 estimated that the impact of shark risk on tourism was 20 million euros per year. So because it impacted all tourist activities, not only blue tourism, due to loss of tourists, that is approximately 10,000 tourists in 2014. And also this figure of 30 million euros can be compared to the investment of the state in shark risk management in La Réunion. And the state has put 1 million euros per year over the 2015-2020 period in La Réunion. So it gives you also an idea of, okay, you invest 1 million, but you know you want to guarantee that income of 30 million euros, and not to talk here about the damage in terms of image. Okay, we also did an assessment of the net primary productivity and the carbon stock. And as you can see, here is the map of the mean primary productivity with higher values in the south of the EEZ and higher values also around the coastline. And we showed that on average, the entire the mean primary productivity production of the ocean is more than 200 milligrams of carbon per meter square per day, which is 90 tons of carbon per kilometer square per year. Nevertheless, most of this carbon is remineralized as CO2 in the atmosphere and isn't stocked, or only a very small proportion is stocked as recalcitrant organic matter on the ocean ground. So, okay, and the final also assessment we did was the fishing activity at the scale of the EEZ. So I won't talk only about coastal fishing here, but more about fishing at the scale of the EEZ. There was in 2018, 10,000 of fish were catched, mostly tuna-like species, for a total market value of 30 million euros. And if we assume that the net factor income represents 60% of the market value, then the value of open ocean fishing can be estimated to an average of 60 euros per kilometer square per year in the exclusive economic zone of La Réunion. So it gives an idea of the monetary value of this service. So I am done with this study where I presented the way we map habitat, the way we assess ecosystem, the habitat status, and the way we assess also some ecosystem services. And I insist it's only a preliminary result here we are presenting, still need validation. And as a conclusion, I wanted to talk a bit about the experience I had interacting with my colleague scientists in La Réunion regarding ecosystem services. And I must say that a majority of scientists interacted with in La Réunion are worried about the ecosystem services approach. because they see it sometimes as a potential threat to very fine-tuned interaction between science and society. So they kind of want to keep control, and I can understand that, over the data and the result we present to our stakeholders. Another reason for being reluctant to the ecosystem service approach was discussable assumptions, because we are using only very low resolution data, and most of the time non-validated evidences on the linkages between ecosystem and society. So we need to improve those data and those methods, and I'm very aware of that. So I chose here to adopt a way of reasoning that can be qualified as absurd, if you want. So you reach at the point where you map ecosystem services, and we may find by the end that this is maybe a dead end to interact with stakeholders. Maybe there are other ways we want to interact with stakeholders regarding priorities for ecosystem protection. So here I'm talking about a conceptual critique against the economic valuation as exposed by Siloren and David. And one way of tackling that issue might be to talk about not only the value of ecosystem services, but maybe about the number of people that are impacted by a loss in the quality of those ecosystem services. That's another approach also. And so finally, I would say that stakeholders locally in Réunion are advised to adopt a very critical stance regarding the temporary results that are presented in this study. I thank you for your